Algebra 2 students, Mr. Thomas, I'm back like chiropractic, ready to teach you some more math. Today, we're starting a new chapter, Chapter 2, focusing on functions, and our lesson for today is going to cover 2.1 and 2, but really the bulk of the lesson is 2.1, and we're going to focus on relations and functions. Hopefully by the end of this lesson, you know what those mean, and the objective is that you'd be able to graph relations and that you would identify functions. So let's get into it. First, a relation is a set of pairs of input and output values, okay? So think of relation as a relationship. A relationship involves more than one person, all right? And so a relation is an input and output. So when we talk about pairs, we have what's called ordered pairs. You're used to seeing this, where the first value is the x and the second value is the y. It can be written as an ordered pair, these relations. A relation can also be written as a mapping diagram. You may have seen this in previous math classes, but notice right here, the arrows point to the relation that matches. So like this value of 4 on the x actually goes to 4, -1, and 4, 3, just like we saw right here. You most definitely have seen this either in geometry or algebra 1, where you have a table. The x's are the first, or the input, and the y's are the second terms, and those are what we call outputs. And then you've probably seen some graphs. So these ordered pairs in graph form. So for instance, -3, +4 is right here. You're going back 1, 2, 3, and up 1, 2, 3, 4, like that. So these are just 4 ways to represent relations. These are all saying the same thing. So sort of like the nicknames I have. In school, I'm Mr. Thomas. To my friends, my name is Jake. To my kids, I'm Dada. To my family, I'm Jacob. 4 different names, same person. 4 different representations, same concept. All right. So what you're going to see a lot of in Algebra 2 is you're going to see these 2 terms, domain and range, okay? So the domain refers to the inputs or the x coordinates. The range refers to the outputs or the y coordinates. The way I remember this is I think of a mountain range. And so mountain ranges, they go up. There's my snow. All right, and so mountains go up, range goes up on the y-axis, okay? So just keep those terms. Remember, if it's in a box, you probably want to know it. If it's in a blue box or if it's in blue, you definitely want to know it. I think you'll learn this, but I'd recommend writing that down anyways. All right, so focusing more on domain and range again, it says find the domain and range of these relations. So all you're going to do to find the domain, we're just looking for the x coordinates. So all these things, they've already highlighted them in orange. All these x coordinates, those are our domains. So we would just write them. Notice it's a little squiggly line on each side. We just include those. That's the domain. Same thing for the range. It's highlighted in blue, and we would just put them in order. It doesn't necessarily have to be in numerical order, as you can see. It's just order of how they're listed. That is finding domain and range. So let's think about relations and functions. So a relation is just a coordinate, x and y, 2 numbers. So what is a function? A function is a relation, so it is a relation, but it's a certain type of relation in which each element from the domain corresponds with exactly one element from the range. So you have to have one element from the domain corresponding with exactly one element from the range. So let's look at that, some examples and see what this means. So it just is asking, is this relation a function? So notice -3 matches up with -2, matching up with only 1. A 0 matching up with a 7, going to match up with 1, and the 4 matches up with the 1. So it says each element in the domain corresponds with exactly one element. So this is a function. This is a function. I'll give it a smiley face. All right. Here, we'll give him a hat too. All right. On this one, all right, we're looking and we want to make sure that each domain, so we have 4, 8, 1, 6, and 4. All right, so we have the 4. So we're looking for that domain. And if we have a duplicate of domains, that means this is not going to be a function. So it says the x coordinates 4 corresponds to -1 and 1. So this is not a function. I'm just going to give that an x. All right, down here. Is the relation a function? Notice we have the 2. I can already tell. The 2 has 2 arrows coming out of it. That's not going to be it. Notice in blue, the same input cannot have different outputs. So that is not. And then let's look at this one. We have -7, 9, 14, and 7. I can already tell you, because there are no duplicates on the domain, we're good. And so this one, however, different inputs can have the same output. So notice we do have a duplicate on the range. That's okay. What we need is we need the domain to only have one match. All right. So this one would be good. Here, we'll do a happy snowman. Look at that. A happy snowman. There we go. All right. So that is finding functions within relations. All right. So a quick way to figure out if something is a function, if it's in graph form, is what's called the vertical line test. So a vertical line is going up and down. So basically it says if a vertical line passes through more than one point on the graph relation, then that is not a function. So right here, notice they draw their line and it hits, I'll use the black, it hits this point and this point. It hits more than 2 points on the graph. This is not a function. No good. No good on that. All right. On this one, on B, notice the vertical line test, it only hits 1 point. So this is looking good so far. Let's circle that one. And then right here, notice when I do my vertical line, it's going to hit 2 points. So the vertical line test will tell us that at any location, it will only hit 1 point if it's a function. So yeah, right there, I only hit 1 point, but because there's duplicates right there, that's not going to match up. And so our answer of which of these is correct as a representing function would be letter B. All right. The next thing we're going to look at is what's called direct variation. And direct variation just means it's the ratio between input and output, okay? So think of ratio as like a fraction. So it says for each function determine whether y varies directly with x. If so, what is the constant of variation and the function rule. So when we think about direct variation, what we're saying is this is the formula to figure it out, where k represents the ratio and y and x are the coordinates. So we could find this by either y equals k times x or k equals the ratio equals y over x. So right over here, it's the way you would determine this is you would set up each of these coordinates and determine, do they have the same ratio? If so, then that is what we call the constant of variation. So notice we have y over x, 2 over 1, 6 over 3, 8 over 4. All of those equal 2. And so the function rule is y equals 2x, and the constant of variation is 2. All right, this is the function rule, and the constant of variation is k. All right, so same thing over here. If we were to try to determine if there's a constant, we would put 4 over 1, we'd put 8 over 2, and 11 over 3. Well, 4 over 1 is 4, 8 over 2 simplifies to 4, but 11 over 3 does not simplify to any of that. And so we would say it is not constant, and it does not vary directly, it doesn't have direct variation, and so this will not be applicable. Right? Remember, if it's in a blue box, have that in your notes. Alright, so how do we identify direct variation? So, it says determine whether y varies directly with x. If so, what is the constant of variation? So, on this one, basically what we're going to do is we want to get it in the form of y equals k over x. So right here it says divide each side of the equation, 3y equals 7x by 3. So we're getting y by itself. And when we do that, so if we divide 3, we will get y equals 7 over 3x. Alright, since we can write it in this form, we would say that y varies directly with x, and the constant of variation is 7 over 3. Now over here, we want to try to get the y all by itself, and we want to try to get in y equals kx form. So if we did that, it's going to tell us divide by 7. When we do that, we get y equals 2x plus 1. And since we cannot write it in this form, because we have this extra 1 over here, we would say this does not vary directly. Okay? So remember, we're trying to get it in this form. If you can get it in this form, as this simplified, then you have direct variation. So here we have a real life problem. A salesperson's commission varies directly with sales. For every $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So it tells us that C equals commission, S equals sales, and then the K is the constant of variation. So we would set this up as y equals kx. X is the input. So the constant of variation we determine is 0.085. So then, once we know the constant of variation, we can just plug it in to this, and we're trying to figure out what is the commission off of $2,300 in sales. And so we would just say that 0.085 times 2,300 would be our commission, and that would be $195.50. All right, that is it. You have about 12 questions. And listen, if you need help, contact myself or Miss Colette. We're here to help you. Good luck. I have full confidence in your ability to finish this assignment. Goodbye.